My name is Hua Jin, and I'm doing my PhD in Southampton University Business School. And my research topic is the impact of tax legislation on dynamic lot sizing and promotion decisions. And I'm writing the dissertation with the help of my supervisor, Patrick Bullens. And in this presentation, I want to show how we precisely consider the tax element in our well-known dynamic lot sizing problems. And tax legislation we are pointed in here, especially for the UK tax rules. So the contents covers is like a basic introduction. We cooperate for the basic text and the literature reviews and the research questions. And the second one is DRSP problems. So with the text models, so it is a standard DRSP problems. And the next one is text adjusted DRSP problems and the solution method and the numerical examples. And the third one is promotion price on text adjusted models with the solution method and also numerical examples. So the research background I have in here is in most operational activities involve the taxes. So it can be expressed in the corporation taxes or value-added taxes. And at the end, the operations will pay for the taxes to the government. So as most operations, they want to maximizing the profit after the taxes, we're thinking these additional expenses should be principally be accounted for their operational decisions. So we're looking at how the taxes works in our supply chain. So it is well known when consumption taxes, we call it value-added taxes. Normally, if we model it, it's a very easy one. It is customers and retailers and manufacturers. So normally the retailer sourcing from the manufacturer and they selling to the customers. So when retailer sourcing from the manufacturer, they pay for the VAT in here. So technically we call it input VAT payment. And also when they're selling to the customers, they also pay. The customers also pay for the output another VAT. So from retailer side, we call it output VAT payment. So at the end, the retailer only pay for the difference to the government. So from here, we can find out there is a timing difference when really the taxes happens, and the retailer need to pay back to the government. So in the literature, we're already looking at in the OR literature, we already find the taxes already applied in the inventory control problems. So this one is 2011, Huzhou 2011, so 2015 one, and they are optimal decision, production decision, depending on the purpose of the tax policies. And another one is we're looking at Miyake 2013 papers, which is modified MPV and the EOQ model, where the corporation tax applied, and their optimal decision is decreases. And lots of the inventory models, it is applied for the taxes, but most of the taxes are treating as a fixed rate. And how it is being collected, how it is being paid back didn't be applied, didn't be explained it. So we can find it out no literature has examined the impact of the timing of taxes. So we're looking at the reason why it is being ignored. So most operations, when they want to maximizing the profit before after the taxes, as epsilon it is the corporation tax rate, as it is a fixed rate, they only need to maximizing the profit before the taxes. And the same for the consumption taxes cases, which is value-added taxes. So when they're selling, they got the output VAT payment. And when they sourcing, they also had the input taxes payment. At the end, they pay for the difference, and the other terms are all canceled out, and only the same like maximizing the profit before the taxes. So we're thinking about if the lot sizing models are based on the average cost functions, it seems like both the CT and the VAT does not have impact on the inventory decisions. But this is no longer true when we're already looking at how the tax is collected and how the tax is paid back to the government. So in this research, we want to find out two things. We want to incorporate for the dynamic lot sizing problems. So it's the DRSP problems is the synchronized with the in and outflow of the tax payment consideration. And if there is impact on this ordering policy, then we're further looking at whether the promotion price considered or whether promotion strategy affected by the tax payment with the decision node. So before we introduce the basic DRSP, we're looking at that tax rules were applied in these models. So we're looking at the two tax schemes. One is VAT schemes. Another one is corporation tax schemes. So VAT schemes, there is 5 different kind of schemes available, and the mostly adopted one, we're using the standard VAT accounting scheme, and this is paid for in quarterly basis and adopted for the large firms. And the same like corporation tax scheme, there is especially for small firms and medium firms and large firms. In here, we adopted for the large firms corporation tax schemes, and also it is based on the quarterly basis, and it should be paid in 1 year time period. So for example, if this is a 1 year planning horizon, this is first time of the accounting year, we're looking at it in this period, all the operational activities happens in this period, will pay for the corporation taxes, the VAT at this point. So the same for the next time period, they will pay next time in 180 days. So this is one of our inventory problems, is a standard DRSP problems. So the object function is only to minimizing the cost. So there is a setup cost, and multiplied by the integer variable about the xi, which is it happens when it is 1, otherwise it is 0. So holding cost, which is calculated for the leftover inventories at the end of the time I, and also inventory leftover can be calculated from here. And the purchasing cost is C, and the amount is QI. And our method is based on the MPV method, so we want to rewriting this object function in the time delay factors. So we're thinking about the setup cost and the purchasing cost happens at the beginning of the period, so discounted by the time element in here. And the holding cost is only happens at the end of the horizons. So we're using the discount factor E minus I alpha T, and the constraint goes the same. So we want to solving out first is MPV based DRSP problems. So the same method we're going to within theorem as a whole. So first time setup cost is needed, and also zero inventory properties hold. So if we want to writing in the arc cost function, the arc cost function, there is a n+1 node in the network from 0 to n, and we want to find out the cost from I to j, which is non-negative demand in that period. So if I is the setup cost happens in that time period, is the setup cost and the purchasing cost in here. So in here, we recalculated the holding cost. So this first one is a holding cost in the first time period, at the end of the first time period. And this one is holding cost of the second time period. And we're rearranging our arc cost function in these terms. So this is MPV-based DRSP problems. And based on this one, we're further looking at how we model our text-adjusted models. So there is 3 main components. One is the MPV of the after-tax revenues, and another one is cost, and another one is holding cost. So revenue is very easily to generate, which is sales from your product or sales from your items. So P and the price is Y is the demand. And then when we're selling this product, we add for the tax payment tau in here, which is pointed for the output VAT payment. And this output VAT payment can be claimed back, but not at the moment, in future times. So this future time will depend on VTI time. So VTI time is the VAT return date. So it depends on the organization's selected scheme. And they will be returned back in this time point. And the same in here. the sellings in here, they generated, there is a profit. So profit, the profit, they have to pay taxes on this time point. So CT, which means the corporation tax, the due date, they have to pay on that time period. And the same method, we're looking at the expenses in here. So setup cost and purchasing cost is the same. When they sourcing the product, they have to pay for the tax element in two parts. And also VAT can be returned on the due date. And the same for the corporation tax, the purpose or the cost for setup cost should be deducted from the payment. So this is how we're doing the MPV of the after taxes expenses. And the holding cost is the same. So after that, we're rewriting for the MPV of the after tax profit in period I. And so the object function is just changed with the basic dynamic lot size into minimizing the cost, and our method is MPV-based tax-adjusted models, and we're rearranging the previous terms in this way, and the condition is the same with the basic DRSP problems. And the solution method we applied in here is a Gilbert 1999 solution approach. So the approach they have also need to maximizing the profit. So they have the solutions with exactly n setups, and n is the number between 1 to n planning horizons. So in here they doing the RTD is the revenue, CD is the cost. So they want to find out in which n value can give them the maximum values. So they want to try when n is fixed, in which node can give them the maximum value profit. And because it's depend on the cost in here, so cost is from the basic DRSP problems, and we know n is fixed, so n setups in here is already been fixed, and also purchasing cost in here is fixed. So the only affected term is this term is a holding cost term. It's depend on the when the production is started. So when n equals 1, we go this recursion method. When n equals to n, we go this recursion method to find out the maximum values. So the same method we're using in our models. So we redenote our problems in the sense of the same Morgan routine series hold, and we're writing GNI, which is profit from node I to n, covers from the period from I plus 1 to n. So which means in here, RI is the revenues. So risk revenues is covers from it. If I is 2, it's covered from period 3 until the ending of the planning horizons. So it is all the same. We're just rewriting for the recursion function, rewriting the functions again with the previous ones. And so the solution method we have is the same, but the recursion method is different. So Gilbert 1999, they only need to recursing for the holding cost terms. But in our problem is because we calculated the time value of the money inside. So every terms like the revenues and the cost is being re-evaluated by the discounting factors. So we're looking at the which n can give us the maximum value. And when n is fixed, which node can give us the maximum profit. So we're looking at the recursion function when n equals 1 is the revenue minus for the expenses. And then we go back n equals 2 to n. And this value is from this formulations and multiplied by the time delay factors. So in order to good understanding, I'm looking this graph. And so the method I have when n equals 1, I calculate from 0 to 4, 1 to 4, and 2 to 4, and 3 to 4. And from here, I find out the maximum values. And when n equals 2, I start to node from 1 until 3, and combined with the previous calculation which I had done in here. And then we still continue to from 1 to 2, and combine with the previous ones. And then we find out when n equals 2, which value is give us the maximum values. So we compare with the previous ones, and continue to do n equals until n equals 4. And based on this solution method, we had some result in here. So this one is we're using the DRSP problems applied in our problems, and this one is text-adjusted models which we're using in our problems. So we find out that in basic DRSP problems, we find out every 6 time period we order 33. 6 time period we order 33. And in our text-adjusted model, we find out in text point date, it is should be order 33. And so it is 60 days. And from here, it is only order 16. And this is 30 time period. So the same pattern happens in another time period. And we're looking at the reason why we have this kind of effect. So for example, if the orders happens in this time period, like 16, the input taxes we paid until we claim back in next tax point, it will remain at cost in our operational decisions. So that's the reason when it is tax point coming, we order a little bit more, and then we can claim back the input taxes on that day, and it doesn't remain as a cost. So at the end, it maybe have 1.3% of the profit different. And from here, we find out there is input taxes will have the impact in our ordering policies. So we're further looking at how about output taxes payment. So we're further looking at promotion price on text-adjusted DRSP problems. And we're looking at very early ones for dynamic pricing. In Thomas 1917, consider the demand function and the cost parameters may vary over the times. And the method is also profit maximization method in here. And they define the subproblem in here again. And the theorem happens in here is a setup cost happens in period I, and until the next setup period J, the optimal price for that period must be set for which is maximizing the values. So using the forward recursion method to decide for the price. And in here, the text-adjusted solution method we are using, we got the original price. Another one is for the promotion price. So promotion price is from the discount price from the original price. And the demand also goes with this price decisions. And we put it in the recursion method to find out our solutions, whether it is different from the dynamic loss sizing problems. So we got some of the numerical examples, and so in this case, if we're using the DRSP problems, the 2 means they go to the promotion price. So in this case, they said do the promotion price the whole planning horizons. But yeah, so but in here said it is only not do the promotions. So there is but in 2 models we can find out in text adjustment model always do the promotions on the tax return days. So which means the output taxes the paid from the customers until the retailer pay back to the government, it remained as a revenue in their operations. So the main conclusion I have in here, the tax rate itself is very important, and the schemes every organization can be adopted is very important. And in this research, we fully take advantage of the features of the input and output tax payment, and which is so in the ordering policies and the promotion strategies. And a very robust insight is that optimal ordering decisions often become synchronized with the tax return points with the standard schemes. And the benefit is considering taxes, especially in the designing a model of the higher product values or lower the marginal profit items. And always in the operational decision, the buyer and the seller is involved in the operational decisions, and the government role is already been neglected. So our research has contributed the government role introduced in the logistic decision. Yeah. Thank you.